Hi guys, so I'm back. I'm having a little bit of trouble with my technology here. I had originally put some little soundbite buttons on different slides in this presentation, but it looks like a lot of those buttons are failing for you guys. So I'm going to do it's going to be a really quick video that I'm going to then upload to YouTube here and share the YouTube link with you, and hopefully that will help you to get through this lesson. I know there's a better way of doing this with these slides than this way. I can't seem to get the full screen preview of it, so I'm just going to go slide by slide this way, and you can still see me as I talk through and try and show you what's going on for this lesson. So we're talking about Canada's climate, and the important thing that you need to remember, so I'm going to go 2 slides down, is that climate means everything that is happening all year long. So what's the difference between weather and climate? When I look outside and I see that it's raining and snowy and windy and cold or hot, that's weather. Day to day is weather. Where climate is what has happened with temperature and precipitation of rain and snow over the course of the 365 days of an entire year. And that's the difference between those two terms, weather and climate. So climate is the average weather in a location over a long period of time. No rain. So for example, like the breadbasket area of Canada in the plains, they don't get very much rain there. And so that is a drier area. They have dry soil and drier natural vegetation like the grasses. Where cold climates like the north of Canada, which is the majority of the north of Canada, is all cold climates. And they might have permafrost soil, less vegetation, tundra, like we looked at before March break. So asking you the question, how does climate affect our everyday lives? Here in the Niagara region, we have seasons. So in the summertime, it affects our daily lives because we have hotter temperatures. We might need to use air conditioning, which means that our bills are going to be higher. Or it means that people vacation at certain times of year, or they choose to live in certain types of houses, either near or far from waterfronts, things like that. So around here, our climate heavily affects our decisions on a daily basis, not just with what we wear day to day with our weather, like I put on a jacket or I wear shorts, but how does climate affect your everyday life? People make decisions about where to live and what kind of jobs to have and where they vacation and how they spend their money, and our bills and things are affected by climate. So I hope you get that idea that climate actually affects the choices we make and how we want to live and where we settle and where people and what people do with their lives throughout the course of a year. So climate refers to the long-term pattern of weather, like we just said. So keep in mind too that Canada is a really large country, and we said that 90% of Canada's population lives on less than 10% of the land. So most Canadians live in that southern 10% area. So actually the majority of our population is right here in the Niagara region and the Golden Horseshoe, which is from us here in Niagara all the way around Lake Ontario to Toronto, Ottawa, Montreal, Quebec City. That particular area is the most populated area of all of the 37 million people that live in Canada. And then there's a few other major cities as we go across most of our capital cities, including Saskatoon and Winnipeg, in Alberta, Calgary, and Edmonton, and then out to Victoria and Vancouver, British Columbia. So the North, we say we the North all the time, right? Basketball players love that. We the North. That the northern regions of Canada, not very many people are living in these regions. We do have populations in some cities in the north, but mostly Indigenous, Inuit, or First Nations people groups or Métis people groups that are living in those areas. Remember that northern area is tundra, so it's permanent permafrost soil that is there all year long. The top might melt a little bit in the summer times when it gets warmer, but it gets muddy. Remember, we talked about that when we talked about tundra climate and tundra soils. And then there's coastal area, and a lot of people do like to live in the coastal areas of Canada. The west coast is much nicer than the east coast of Canada. When it comes to the climate year-round. They don't get as much snow and ice and things in the west as they do in the east. So weather means short-term, day-to-day. Hot, cold, wet, dry, calm, stormy, balmy, humid. So you need to know the difference and be able to differentiate. How does weather affect your daily life? Well, daily I might go, okay, I need a jacket today. Or daily I might be like, oh, I need to scrape the ice off my windows. Those are the smaller day-to-day things that affect our human systems. So long-term weather patterns are calculated on temperature, precipitation, atmospheric pressure, and wind. And so in this unit, we're going to break these down in a little bit more. That's going to make more sense in a moment. And Canada's climate has a variety of all of these things because of its size, because of the fact that we go from below sea level to way above sea level in high elevations. We have three major oceans, the Pacific, the Northern Arctic, and the Atlantic Ocean surrounding our country. And we have a massive wind system that sweeps across the entire country. So because Canada is so large, our climate is varied, meaning it has lots of different variations, and we see different climates all across the country. So the way we break this down is this acronym. LOWERN. So L stands for latitude. We're going to go through that. We're going to break each one of these ones down. O is ocean currents. W means wind and air mass. E is elevation. R is relief. And N means nearness to water. So we're going to break each one of these down a little bit more. So this first one, latitude, this should be a review for you. We studied longitude and latitude at the beginning of this course. And I always kept saying that latitude is fatitude. Imagine like the belly of a fat man, that the equator is like a belt across his belly and that it runs horizontally. All of the latitude lines run horizontally all the way up to the north in the northern hemisphere, and from the equator south to the southern hemisphere. Those are the latitude lines. The further away from the equator you get to the north, the colder it gets. The further away from the equator to the south, the colder it gets. The hottest place on the earth being that equatorial band right at the center of the Earth's 0 latitude line. So what is latitude? Can you answer that question? What are the main lines of latitude? The main lines of latitude are on a map that I'm going to show you in a moment. And how do you think they impact climate? So you can kind of ask these questions now. You need to be able to answer those questions after the next couple slides. So here's the main lines of latitude. So here's the equator. And then we had done this before. This should be a review for you. We have this section between the equator and this line is called the Tropic of Cancer. Between the equator and this line is the Tropic of Capricorn. Between the Tropic of Cancer to this line here is actually called the temperate area, temperate north. And from the Tropic of Cancer to this line, it's called the temperate south. And Canada actually exists in the temperate north region, which is why we have what's called a temperate rainforest in BC. And we say that our climate here in the Great Lakes area is a temperate climate. That just means kind of medium or average. We have 4 seasons usually in temperate climates. And then up in the northern hemisphere or in the southern hemisphere, you have Arctic. You have frozen polar temperatures. So latitude determines the north and south positions of the Earth's surface. We measure it 0. We start with 0 at the equator and we go north and it goes up to 90 at the North Pole. We start at 0 and we go south to 90 at the South Pole, and each of these horizontal lines has its own measurement. The further away from the equator you get, the colder the temperatures get. So how can we explain latitude and how it affects climate? So here's your answer. The distance away from the equator is the key factor in determining whether the region has a hot or cold climate. We're pretty far away from the equator here in Canada, and for that reason, we have colder temperatures and we have longer winters. So here's an example of what the Earth's tilt does. So the sun is coming at us and a direct sun rays are hitting the Earth, but the Earth is tilted. The Earth sits on an angle. And so during the summer, we get more direct sunlight rays from the sun hitting Canada. This is Canada here. And because of this, we have longer, hotter summers. But as the Earth rotates around the sun, it tips us away. And so then in the winter, we're actually further away from the direct rays of the sun, and we have darker, shorter days. Sometimes it gets dark around 4:30, and it's still dark when we get up in the morning to go to school, and it's dark when we come home. This is the distance that is pulling us away, is what is creating difficulty for us to feel that warmth of the sun throughout the year. So also that angle of the sun is really heavily impacted by the tilt of the Earth. The summer sun is higher and more direct, and so it's hotter, and the winter sun is more angular and it's not as direct, so it's colder. And so in the wintertime, usually from sunrise to sunset, it's much lower on the horizon, where in the summertime you have that high noon, high sun that is much higher in our atmosphere. So this particular graphic just gives you a little bit more information about the summer equinox versus winter equinox. I'm not testing you on this, but it's just for your information. So you can see how that rotation of the Earth away and towards the sun changes with our seasons. So watch this video, and that will help you to understand a little bit more about latitude. So now let's talk about ocean currents. All of the oceans of the Earth either have warm or hot currents that run through them. And depending on where those currents are, the land that is immediately next to those currents is then affected by the warm or cold temperatures created in the air from the water below. So for example, here's Canada and the United States, here's North America. Up our western coastline of Canada, we have both a warm current coming up, but then also a cold current. So the Pacific has this Californian cold current that's running down, and Alaska is kind of circulating down. Notice it moves in a circular motion. And then you have similarly convection currents. Remember convection currents, where hot goes up and cold goes down? Well, basically the hot and cold water currents are doing that. They're moving in circular motions up the coastlines. So this warm water current will take the warmer water from the Pacific and run it up this coastline, which means this side gets a lot of rain. Similarly, over here we have the Atlantic Gulf Stream, and it's also a warm water current, which means that this side will also get a lot of rain. These are actually, this is the direction that most hurricanes form out here in the middle of this North Atlantic gyre, and it moves through and hits the Caribbean islands or into the Gulf of Mexico, and usually hurricanes will move up the coastline of North America. Now, St. John's, for example, in Newfoundland, they will get hit either with warm, rainy seasons and things like hurricanes might blow through here, but they might also get cold blasts that come down from the northern Arctic. So what you need to know is that North America is affected by warm water currents. Warm North Pacific currents heat the cold and cool the moist air. And when you have hot and you have water, you end up with moisture in the air. So like we had talked about with convection currents, when you heat a boiling pot of water, you get steam, you get the bubbles, and eventually you get steam and evaporation. And this is what's happening, and it forms clouds. You get warmer water currents in the ocean, it's going to evaporate and form more clouds up in the sky, creating more storms. British Columbia has a milder climate, and so they have a lot of storms. They get a lot of rain. Some areas of British Columbia and the Yukon report over 300 days of rain a year. So Canada's east coast is different because you have that combination of that cold water current and the warm water current that are kind of meeting. And because of this, you get a lot of fog. So Newfoundland's actually, and St. John's is actually really known for really heavy fogs and gray, rainy days. And in the wintertime, they can get a lot of blizzards and really heavy snowstorms and a lot of ice because of the cold that's coming down. So this is what the ocean currents look like. They're kind of like a highway system. And so there's literally water that we know that goes from the Pacific Ocean that eventually moves all the way around into the Atlantic Ocean and back down and around again. This has actually been proven by how much plastic is in the ocean currently. There's been a lot of studies on plastic pollution, and they're actually showing how plastic pollution can actually travel from the Pacific Ocean into any of the other oceans around the world, and that's because of this great ocean conveyor belt that is sending the floating plastic garbage around the world on the ocean currents. The color of these slides shows you which currents are warm, and you can see cold goes down or is more southerly, and sinks eventually. And so, yeah, they get warmer and they move to different areas around the Earth, warmer mostly at the equatorial line. And then, yeah, they move different directions, heating and cooling depending on where they're moving on the planet. So here's a video that you can watch later to help illustrate ocean currents. So let's talk about wind and air masses. The big thing you need to remember with wind and air mass in Canada is that it moves always from the west to the east. So from British Columbia east past us out to the Atlantic Ocean. Now in the winter time, usually we have the polar Arctic climates that are dropping down. So our wind and air masses are going to move things in a west-southwest kind of direction, down from the north. And in the summertime, the warm air from North America is going to be coming up. And so we have warm air coming up in the summers from the south, and that moves in a northwest direction across Canada. When we were looking at latitude lines, we talked about tropical, temperate, polar, and Arctic. So this slide is basically illustrating how we have different temperature zones according to the latitude, but also the wind and air mass kind of keeps those particular temperatures in particular areas the same year round. So in tropical areas or areas that are close to the equator, the wind and air masses are going to be much warmer. In temperate, the wind and air masses are going to be more seasonal depending on the season of the year and the angle of the sun. The wind and air masses are going to be very cold and stay very cold in both the polar and Arctic regions. And something else to know is that there's a difference between maritime climates and continental climates. Maritime means anywhere where there is water and large bodies of water or over water, and continental is any areas that are land. Wind and air masses have high and low pressure systems. So a lot of times when it's very dry, we have what's called a high pressure system, and when it's very full of moisture and all that moisture in the air is being weighed down and that condensation is being pulled down and it builds up, we create low pressure systems. And so a lot of times when it gets really, really rainy, they'll say, oh, it's a low pressure system that's moving through. If you have a meteorologist like on the TV that's like, oh, low pressure system is coming through, it will bring rain. And high pressure is usually when it's nice and bright and sunny outside and there's sun in the sky and the clouds are really, really high, and that's usually a high pressure system. And then prevailing winds are like what I just talked about with the winds moving from the west of Canada to the east across Canada. And that we call those the westerlies. And Canada's prevailing winds, again, like I said, in the summer they move from the south up, so they're moving in a northeast direction, and in the winter they move from the polar areas down, so they move in a southeasterly direction. So this is a picture that shows you the difference between maritime and continental. So up here in the north, we call this climate zone up here continental Arctic. It is bitterly cold and bitterly dry, and continental because it's mostly land and frozen ice. Here in the middle of Canada, we call this the continental polar as well, where they get a lot of cold air that blows down from the north, and again, it's all mostly land. Here on the west coast, you have maritime polar, which is cold and moist air, and it's moving in a westerly direction across Canada this way. And the maritime polar climate does kind of circle back around, so that we're moving from west to east, but those cold climates seem to circulate, and so sometimes we get some cold and moist air that's coming down from this region and hitting this area as well. And then you get maritime tropic coming up from the south, and maritime tropic coming from the south here, continental here in the land. So what's important to remember is that continental means land and maritime means over the water. So here's a model that illustrates the airflow of how airflow moves. And so here you see this polar front line, or this red line here shows you this movement of air that goes from the west of Canada across to the east, and how sometimes in the winter we get polar climates that come down from the north and make it colder, where in the summertime we get these westerly winds blowing warm air from down here across and north towards Canada. So a polar front just means cold, dry air from the north, and that's really all you need to know from that. It's called a jet stream. That is the movement of the air, and high pressure is nice and clear, and usually either very cold in the winter or very hot in the summer. And the air is moving very fast, where low pressure systems are slow moving and usually full of a lot of moisture. So this is like what the meteorologists show on a news broadcast. This is showing you a westerly, and the L stands for low. So this region's got a low pressure system, so there's more moisture in the air. This area has a high pressure system, so it's probably really super sunny. So it's probably sunny in all these areas where there's an H. Here, this is the Great Lakes region. There's a low pressure system here, and you can actually see all these clouds. This low pressure system band shows us that there's clouds there. So usually low pressure systems have a lot of rain coming with clouds. You can definitely see a low pressure system here with lots of clouds. So this is just showing you kind of how they can have lots of high and low pressure systems moving across Canada. All right, now elevation is really important as well. It basically is that the higher up on a mountain you go, the colder it gets. That's really all you need to know about elevation. There is a lot more air pressure. The higher you go up in elevation, the air pressure changes. There's also less and less oxygen the higher you go up, and the effects of gravity are also harder the higher you go up. And so, for example, like a mountain hiker might really experience that pressure, the air pressure, and the effects of low oxygen, and they might feel their pack as they're hiking to be really heavy, and that's because of all of those effects that happen. The higher the elevation, the more difficult things are. So what that does as well is it affects clouds. So if clouds are coming up against mountains and they're full of moisture, there's also less air pressure, less oxygen, and more force of gravity pulling down on those little molecules of moisture, and it's more likely to dump rain and snow down on higher elevation mountains. So this is a great example picture that shows you not only is the temperature up here on the top of the mountain much colder, even though it's closer to the sun, it's still much colder because of the low pressure, low oxygen level, and more gravity. It pulls the moisture out of the air, causing rain and snow to fall and freeze on the mountains. So we call that a dew point. A dew point is a point where the temperature gets low enough to cause the moisture in the air to fall. So when you wake up in the morning and there's all sorts of dew on the grass and everything's wet, it's because there was a point in the night or in the early morning hours where the temperature was just right to change the vapor or the evaporated water in the air into liquid, and thus water molecules form on blades of grass and on trees, and that's why everything's kind of wet. Condensation is what occurs there, where things become liquid from vapor. And in a cloud formation, when that happens up in the sky, up at higher elevations, it becomes rain or snow. And this is why rain and snow fall in stronger amounts up on mountaintops. These are just questions that a geographer might ask. I'm not asking you to answer these questions, but these are things that they might consider. So they might say, how far will the air rise before condensation begins? So when there is vapor in the air and it's rising and rising and rising, like how far will it go before it reaches a temperature and an elevation where it becomes a water molecule again and then it falls back to the earth? Or how much will the temperature drop in this distance? So as you go up a mountain, for example, why does it get cooler and cooler and cooler as you go up the mountain? That temperature drop has to do with distance as you go up higher and higher elevations. Or how far will the air mass rise for condensation to begin? So if you had a cloud that was really low hanging, the higher and higher and higher it goes and the more pressure is on that cloud to make condensation, like at what point is that condensation going to become precipitation and fall? How much will the temperature drop in this distance? That's actually on there twice. I'll have to edit that. And what will the temperature be at the top of the mountain? So if it were, say, like 30 degrees and really super hot down at sea level, and you have a mountain, what will the temperature be? How much cooler will the temperature be at the top of the mountain in comparison to the sea level? That's something that they look at a lot in BC because there's ocean level, sea level, and then there's mountains that shoot up really close to the coastal edge. Well, how can you have snow on the top of a mountain in July when it's actually 30 degrees Celsius and hot down at sea level? How can it be freezing and still snow at the top of the mountain? Same season, same time of year, but it has to do with elevation and how cold it is at the top of the mountain versus at the foot of the mountain where it's warmer. So here's a video for you to watch on elevation and climate. Relief occurs in mountains. Relief precipitation is created when air masses rise over the mountain barrier. So you have the mountain, and actually I'm going to illustrate this. I'm going to illustrate this with a picture in a second here. So it's when air mass rises up over a mountain barrier, the moist air rises up with the windward slope, and it cools to become precipitation. So I want to show you that in a picture. I will show you what leeward slope looks like on the other side and rain shadow. We can do this best with this picture. Okay, so I want you to imagine this is the Pacific Ocean, and this big massive piece of ground represents all of the province of Ontario. So if I were over here in the Pacific Ocean, there's going to be a lot of evaporation of this liquid from the ocean that will form into clouds and make condensation, so condense into the clouds, into vapor turning into little water molecules up in the air. And as this cloud moves in a westerly direction, we know the wind and air mass always moves from west to east, it's going to push the cloud up against this mountain. So more and more clouds are going to start building up and building up over this particular area to the place where it's just going to be nothing but clouds. And so this side of the mountain will be really cloudy, and they will get big and dark and heavy. And you guys have all seen what happens with clouds when they're big and dark and heavy. Usually you get a storm, and eventually that precipitation is released. So this is the windward side of the mountain. The windward side of the mountain is the side that gets all the rain. And it's because all those clouds have backed up like a traffic jam, and they all have to pee, for lack of a better analogy, and they just can't wait anymore, and eventually they relief precipitation. They relieve all of their rain and snow on this side of the mountain. But on the other side, as the wind and air masses blow the air over the top, well, they've released all that precipitation, so notice there's no clouds over here. This side's going to have less moisture. This side's not going to have as much rain. It's actually called a rain shadow. It doesn't get rain really at all, and so this side is very dry. This is what happens with British Columbia and Alberta, because the Rocky Mountains, this high ground area represents the Rocky Mountains, acts like this wall that's basically a barricade that is keeping the wind and air mass from blowing the precipitation all the way across to the plains. And so it rains really heavy on this side, and everything on this side is a temperate rainforest. But over here on the eastern side of the Rocky Mountains, it's super flat, it's dry, and it's grassy because it's the plains. And so this relief precipitation is a great illustration of what happens with the Rocky Mountains with the divide between British Columbia and Alberta. So here is an actual cut where they put in the areas. So here's the Pacific Ocean, here's Tofino, which is right at sea level. We have Victoria Island, Vancouver. We have the first set of mountains. This would be like Whistler and that area. and then Kelowna, BC, up to the higher peaks of the Rockies in Banff National Park and Glacier National Park that go across the Columbia Mountains and the Rockies, and then out to, say, Calgary, where it starts to flatten out again and it becomes plains. You can see that there is relief precipitation that happens on this windward side of this first set of mountains right off the ocean. Some of it's going to get across, and this area might get a little bit, but can you imagine how dry it is by the time it gets here? All of that precipitation was let off on the sides of this mountain, or maybe this one, but it's never really going to get over here. So Calgary is actually quite dry. So this is an illustration that shows snow. This can happen with snow, not just rain, where you have the westerly winds that are blowing across and show that there is relief precipitation that happens a lot more with mountains. So this is the Great Lakes. I don't know if you can see, but there's an outline of the Great Lakes here in this map. I'm just going to put my marker right here. This is Lake Erie. And you can actually see that there's a tremendous amount of relief precipitation. We have high levels of precipitation in and around these continental areas of land, but this relief precipitation is shown because when water moves, when water vapor in the air moves across and hits land, then it relieves itself. So here's another video that will help you with a tutorial on relief precipitation. And the last one is nearness to water. So if you live near water, it's going to rain more, period. So coastal regions, it rains more. Coastal regions are also milder in temperature. So in BC, on the western coast, it's very wet. It might rain close to 300 days a year, but it's also milder temperatures. They don't get as much snow and ice as what we do in other areas. Where continental regions are usually very cold, or they're very, very hot in the summertime and humid. So you get a different type of climate in coastal regions than you do in continental regions. Now, it's kind of tricky here. Here in the Great Lakes region, we have major bodies of water. The 5 Great Lakes act like an ocean. However, technically, we are a continental climate. So because we have a continental land mass and we're surrounded by land, but we also have these major lakes, it gets a little bit confusing. So this particular area is called a modified continental because sometimes we get things like lake effect snow, where there's a ton of moisture that gets sucked up from the Great Lakes and then it gets dumped down onto the land. And that's what we see here in the Buffalo and Fort Erie area. There's 2 really cool videos here that explain. There's a 3D image video here that shows you, and actually some footage of the Fort Erie and Buffalo area of lake effect snow. So here's some other videos that will help you understand this idea of how land and air kind of work together for precipitation and changing climate. And so then we end up with these climate regions. So the climate regions look a lot like the landform regions. They're not exactly the boundaries of the landform regions, and the boundaries of the climate regions don't match exactly, but they're relatively similar. We have an Arctic climate, so it means it's all frozen all year long. It never melts. The taiga climate has that thick permafrost that's there all year long, but it does melt in the summer a bit and get a little muddy. And you have low-lying trees and shrubs and muddy areas here. You have this area that kind of follows the Cordilleran. Cordilleran means mountains, so your Rocky Mountain region. And so that climate's going to be different than this climate here, which is that temperate rainforest Pacific Maritime. This whole region here is what we call the southeastern. It covers a lot of the area of the Canadian Shield and the plains. And this is just a cooler climate that gets a little bit more rain, but fairly dry. Continental climate. It's very dry here. So this yellow prairie area is much drier here. In fact, there's actually even desert. So about here where my marker is north of Regina, Saskatchewan is actually the only desert that exists in Canada. It's very, very dry. This region is this one here was the boreal. So you have the boreal forest with coniferous trees. This one is the southeastern region where we are, and we get those mixed trees, those coniferous and deciduous trees mixed because of the climate and the soil being mixed in 4 seasons. And then you get that Atlantic Maritime out here, which is rainy and snowy. So different than the Pacific Maritime, they're mostly just rain, where the Atlantic Maritime gets both rain and snow because they're getting that northern Arctic blast that comes down the coastline mixed with the warm water current that's there. So important things that you need to be able to do. You need to be able to tell me the difference between climate and weather. You need to be able to talk about what type of vegetation and soil you might find in these regions and what permafrost is. You should be able to identify latitude, ocean currents, wind and air mass, elevation, relief precipitation, and nearness to water. You should be able to tell me the difference between a continental climate versus a maritime climate. You should be able to differentiate tropical zones on the planet versus temperate, polar, and Arctic zones. And that you can look at the latitudes map back for that one. What's the difference between a windward side of a mountain and a leeward or dry rain shadow side of a mountain? And lake effect snow. What is lake effect snow and why does it happen? So what you guys need to do with this is, oh, do I have one more? I thought I had one more here. Sorry, I'm having trouble with me. There we go. So your learning goal was, can you identify the processes and patterns that affect climate in Canada? LOWERN, L-W-E-R-N, is the 6 factors of climate. So by breaking it down, hopefully you can remember all 6. Once you feel like you've gone through these notes and you've watched the videos and you've watched this video and you feel like, okay, I totally get this whole idea and I know a little bit better, then log into Edsby to the quiz that is posted there and take that quiz. And it is just 8 multiple choice questions and 3 short answer questions about this PowerPoint. You can take it anytime from the time it's posted until Sunday night. It's going to turn off, so the quiz will not be available for you to fill in after 11:45 p.m. on Sunday night. So sometime between now and Sunday, take the quiz. And you'll be able to use your notes. They're there for you. There might be times that I ask you not to use your notes and resource them, but you are home and you're able to access your notes. And for this particular lesson, that's okay. So you don't have to sweat it about taking a quiz and not being able to have anything near you. At this point, it's still okay. So if you guys have any questions, we are going to be together on Thursday, and I will be doing a Zoom room with you guys and meeting as a class. So if you have any additional questions or want anything explained about this 3.1 lesson, you can log on then, and hopefully I'll be able to help you explain. Okay, I hope you guys have a good day. Bye.